Bright Tuty. Every student matters.
Hello dear students, today we'll be taking up the numericals based on the lenses, that is the convex lens and the concave lens. And before doing that, we need to recall the formulas that we are going to use while doing these numericals. First of all, we are aware of the lens formula. Now what did this lens formula that we did previously was 1 by f is equal to 1 by v minus 1 by u, where we are aware that u is the object distance, v is the image distance and f is the focal length. Fine. Second formula that we will be utilizing while doing the numericals is that of magnification, represented by small m, given by the formula h2 by h1, and it was also equal to plus v upon u. Fine. So h1 is the height of the object, h2 is the height of the image, u, as we know that it is the object distance, v is the image distance. Fine. Using these two formula, we are going to attempt the numericals. Plus, we also need to recall the sign conventions. The sign conventions given by New Cartesian system, and those sign conventions we have already done, taking the minus and the plus signs depending upon where the object is and where the image is getting formed. Fine. Now students, the questions that you will be getting in your exams, let us see what type of questions you are going to get and how you are going to attempt them. Initially, we need to remember whenever we are attempting the numericals, we'll be always specifying whatever is given in the question, whatever is to be calculated, we need to take care of the units, we need to take care of the signs. Fine. And I have also mentioned in my previous lectures that we always need to specify, we don't have to directly use the alphabets U, V, F, H1, H2. We need to specify initially what are these U, V, F, H1, H2 symbolize. Let us see. This is our first numerical that we'll be taking. A convex lens of focal length 10 centimeters. So, given to us in the question is the focal length. Now, this focal length, we have to write it specifying it. In the bracket, we are mentioning that we are representing this focal length with small f. This is given out to be 10 centimeters. It is placed at a distance of 12 centimeters from a wall. Fine. So now we are given the distance of the wall from the lens. Now students, whenever we are given the distance of wall or screen from the lens, we are always going to assume that the image is going to be made on that wall or on that screen. So whenever the distance of wall or screen is specified in the question, that means we are given the image distance. So the image distance represented by small v is given as to be 12 centimeters. How far from the lens should an object be placed? So what we need to find out, to find or to calculate is the object distance, and this object distance is basically represented by small u. So this is the object distance that we need to calculate so as to form its real image on the wall. Now this real word is quite important. If we remember our ray diagrams, the position of object and the position of image, we need to recall that always whenever there was a real image formed by the convex lens, it was always on the right hand side or behind the lens. So if I take it the lens, then the wall must be placed here somewhere. The object distance, object is kept in front, and we need to calculate the object distance so as to form an image on the wall. Got it? Now we are given focal length and image distance. We need to find the object distance. Before using the formula, we need to see the sign conventions. The focal length of a convex lens, it is behind, so we will take it to be positive as per new Cartesian. The image distance, because it is a real image, this is important students. Because it is a real image, we are taking it behind the lens. That is why we are putting up this positive sign. This was quite important, because otherwise if it would have been a virtual image, the virtual images are formed in front, we'll be taking minus sign in that case. So this you need to remember, what all information is given in the question and how to interpret that information. Now the question is quite easy. We just have to find the object distance. We know that 1 by f is equal to 1 by v minus 1 by u. And how do we know that? We need to specify this is by lens formula. Right? Now putting the values of what all is given, focal length and the image distance in above formula, we get, what do we get here? 1 by f. 1 by f was given to be, the focal length was 10 centimeter and the image distance was 12 centimeters. So we get 1 upon 10 centimeters is equal to 1 upon 12 centimeters minus 1 upon u. Fine. Keeping minus 1 upon u here only, we will take 1 by 12 on the other side, and now it becomes 1 by 10 minus 1 by 12. Of course, in centimeters, we will use the units later on. So now the equation becomes minus 1 by u is equal to, taking the LCM, and when I take the LCM of 10 and 12, I'll take it to be 60. Right? So it becomes now 6 minus 5. So minus 1 upon u comes out to be 1 upon 60 centimeters. Taking the reciprocal, minus u is equal to 60 centimeters, or I can say that u is equal to minus 60 centimeters. U was the object distance. This is equal to 60 centimeters, and this minus sign indicates that the object is in front of the lens as per the new Cartesian system. Fine. So this is how we'll calculate if two things are given in the question, and then we need to relate what exactly is to be calculated and how. Fine. Hope you have understood it. Let's take another example. Now the second question that we'll encounter is, let's see, an object 7 centimeter height. Alright, an object of 7 centimeter height. So once again, in our solution, what is given to us? Height of object, height or size, it's one or the same thing, and we represent it with h1, that is given out to be 7 centimeters, is placed at a distance of 12 centimeters. So object distance is given to us. Object distance represented by small u is given out to be 12 centimeters from a convex length of focal length 8 centimeters. So focal length is also given to us in the question, represented by small f, that is equal to 8 centimeters. This is what was given to us in the question. Now what we need to find? We need to find the position, nature and height of the image. Position of the image means we need to find out image distance. Image distance represented by small v, that has to be calculated. The nature, in nature we will be checking out whether it is a real image or a virtual image. We will be checking out whether it is an erect image or inverted image, right? And the height of the image. So height of image is to be calculated, represented by h2. Fine. Now, this is what we are being given by initially writing down all the things what are given and what are to be calculated. The second step was looking out for the units which are all okay, seemingly fine, all similar, and then sign conventions. Now, the height of the object is always taken to be positive because the object is erect. The object distance is always taken as negative because the object is always in front of the lens. The focal length of a convex lens is taken out to be positive. I hope you are getting the importance of these signs, because otherwise all our calculations will be messed up and our answer will be wrong. So these sign conventions are the most important part while you are attempting the numericals of this particular topic. Fine. So now we know that first of all, I'll calculate using the lens formula 1 by f is equal to 1 by v minus 1 by u. This was by lens formula. I repeat, we need to specify everything in our exam, right? And now since I have just written u, v, f, what they represent, that is why I can use the formula directly. Fine, because they all u, v and f, they are already being mentioned. So putting the values, which values are given to us? We are given the focal length, we are given the object distance. So f, we know, we'll put the value 1 by 8 centimeters is equal to 1 by v, we have to calculate, minus 1 upon u. U is given out to be minus 12 centimeters. Fine. So now it's just simple calculation that we need to do. Let us see. So I'll say 1 by 8 is equal to 1 by v. This minus and minus sign will convert into positive 1 by 12 centimeters. Right? Taking 1 by 12 over here and keeping 1 by v over here only, I'll get 1 by 8 minus 1 by 12. Simply now I need to take the LCM. LCM I am taken out to be 24. This is 3 minus 2. So v comes out to be 1 by v is equal to 1 by 24. Taking the reciprocal, I'll get v is equal to 24 centimeters. V represents the image distance. So the image is formed at a distance of 24 centimeters. And because our V is coming out to be in positive, this positive sign represents that the image is formed behind the lens. Right? This is behind the lens. Got it? Then after finding V, this is what we have got. Another thing we need to calculate was the height of the image. Now for height of the image, we'll put up the formula V upon U was equal to H2 by H1. V we have just calculated 24 centimeters. U given in the question was minus 12 centimeters is equal to H2 is what we are going to find out, and H1 was given to be 7 centimeters. Fine, just cutting it off, 12 1 the and 12 2 the, this comes out to be 2 is equal to H2 by 7 centimeter. It is in minus, this minus sign remains, and cross multiplying, H2 is equal to minus 2 multiplied by 7 centimeters, that comes out to be minus 14 centimeters. This is our H2. Now H2 signifies the height of the image, which is 14 centimeters, and this minus sign represents that this is an inverted image. Got it? So this is an inverted image, and as per our previous knowledge information, we know that inverted images are always real images. So in the question, I was being asked as to find what? I was asked to find the image distance, that I have found out. I have been asked to find the height of the image, and I was asked to tell the nature of image. So the nature of image comes out to be that it is a real image and it is an inverted image. This is what I have interpreted with the signs of the answers that I have got. Whether it is V, which was positive, telling that it was behind the lens, and H2, height of the image, which was negative, telling that it was an inverted image, and inverted images are always real. Fine. So this was our second question. Hope you have understood it. Let us see one more question. An object 60 centimeters from a lens. What we are given in the question is object distance. Object distance represented by small u is equal to 60 centimeters. Gives a virtual image. Now, the virtual images are always formed in front, that we need to remember, right? We'll be using it in sign conventions. Virtual image at a distance of 12 centimeters in front of the lens. Otherwise also, if it would have not been specified in front, it has made our work easier. But otherwise, by just looking at this particular word, virtual, we could have interpreted ourselves that it would have been in front of the lens. So now we are given image distance. The image distance, that is V, is given out to be 20 centimeters. What is the focal length of the lens? So we have to find the focal length, that is small f, right? Is it the lens is converging or diverging? Give reasons. This part will be taking after finding the focal length. So given and to find we have written. Now the sign conventions, object distance always taken to be negative because it is always formed in front. Image distance is also specified that it is in front. So we'll take minus sign. Now we know that lens formula 1 by f states that it is equal to 1 by v minus 1 by u. This is our lens formula, right? So putting the values, of u and v in the above formula, we get 1 by f is equal to 1 upon, now v is given to be minus 20 centimeters minus 1 upon u is given to be minus 60 centimeters. Fine. So what does this equation become? 1 by f is equal to minus 1 by 20, minus and minus become plus 1 by 60. Now I'll be taking the LCM. LCM is taken out to be 60. So it is minus 3 plus 1. Fine. So it comes out to be 1 by f is equal to minus 2 upon 60. Cancelling it out, it comes out to be minus 1 upon 30. Taking the reciprocal, focal length is minus 30 centimeters. Now I have got the focal length to be 30 centimeters and this minus sign indicates that the focus is in front of the lens, right? We have got two lenses, one was convex lens and another was concave lens. Our convex lens always converges the light rays like this and the principal focus was formed behind, which was as per new Cartesian system would have been taken as positive, and the concave lens always diverges the light rays, because of which the focus is formed on the left hand side and taken to be negative. Since the focus is negative, that means it is a concave lens, and if it is a concave lens, then it is a diverging lens. So as per what we have been asked in the question, whether this lens is converging or diverging, we will say that it is a diverging lens. And when it comes to giving the reasons for our answer, we'll state that it is a diverging lens because a concave lens has a focus in front of the lens. That is on the left hand side of the lens. As per new Cartesian, it is minus. Got it? Fine. So these are a few questions that you will be getting as far as the lenses are concerned. Right? Next question. A 2 centimeter tall object. What exactly is being given to us in the question? The tallness, the height, the size of the object. So this is height of object, which is given to be 2 centimeters, taken as h1, is placed 40 centimeters. That is the object distance. So the object distance is also given to us in the question, represented by small u. This is taken to be 40 centimeters from a diverging lens. Diverging lens means it is a concave lens. The focal length is given to us. The focal length of this concave or diverging lens is given to be 15 centimeters. Find the position and size of the image. We have to calculate the position of image, that is the image distance, represented by small v. This is we have to calculate. Secondly, we have to calculate the size or the height of the image, h2. So time for sign conventions. Height of object is always taken to be positive because it is an erect object. Object distance always minus because object is always placed in front of the lens. Focal length could have been plus or minus, but because it is specified that it is a diverging lens, concave lens, and the focal length of concave lens is always minus because the focus formed is always in front. Right? Now putting these values in our formula, once again we know that one by f is equal to 1 by v minus 1 by u. This is through lens formula. Putting the values. Putting the values of u and f, we get u is given out to be minus 40 centimeters, f is given out to be minus 15 centimeters. So 1 upon minus 15 centimeters is equal to 1 upon v minus 1 upon u. U is given to be minus 40 centimeters. Fine. Opening up, minus 1 by 15 is equal to 1 by v, minus and minus sign we know that will become plus, plus 1 by 40. Now keeping v over here, I'll take 1 by 40 over on the left hand side, minus 1 by 15 minus 1 by 40. Taking the LCM, 1 by v becomes, I am taking this LCM to be 120. Right? So it becomes minus 8 minus 3. So this is 1 by v is minus 11 upon 120. Taking the reciprocal, v is equal to 120 by 11 centimeters, which is in minus. I can just calculate it till 2 decimal places. That will be my answer. And the main thing is this minus sign signifies that the image formed is in front of the lens. Right? This is what I have got, image distance. After that, I'll be taking up the height of the or size of the image. Right? We know that magnification formula states v by u is equal to h2 by h1. Fine. V I have just calculated. I am just putting it like this only. so that to make the calculations a bit easier, divided by u was given to be minus 40 centimeters is equal to h2 I need to find out, and h1 was given to me in the question to be 2 centimeters. Fine. So putting it 2 centimeters. Alright. Now I'll express it like minus 120 by 11 divided by 40, just in order to avoid any kind of calculation error, is equal to h2 by 2. So this becomes minus 120 by 11 multiply by 1 by 40 is equal to h2 by 2. Now cancelling this thing, I'll get h2 by 2 is equal to minus 3 by 11 centimeters. Now just cross multiplying it, h2 becomes minus 3 by 11 multiplied by 2. So now my h2 becomes minus 6 by 11, and minus 6 by 11, if I calculate, it will come out to be approximately minus 0.55 centimeters. So this is number 1. This particular image formed will be in front, and it is the diminished image of the object getting formed. Fine. This minus we must have just cancelled out above, right? And this is a concave lens, that is why the image formed, we have not deducted it upwards, so that is why the answer was coming out to be minus. You see, this is how we can even check the answers. Like the answer is coming out to be minus, minus sign in case of image represents that it is an inverted image. But because it was a diverging lens, it was a concave lens, we always need to make sure the answer should come in positive, because a concave lens always forms an erect image. So if we forget something like we did over here, cancelling the signs, if we make an error like we did here, taking the minus sign over here, we can counter check with the basic fundamental knowledge that we have about the lenses and the image formed by them. Fine. So if the image formed is less than 1, it is a diminished image, and it is an erect image, which is a characteristic property of all convex lenses. Fine. So this is all about our lenses and a few numericals based on our lenses. There are numerous numericals that you can practice. There are so many questions given from other reference books also, and from NCERT. You can just attempt them all. All are based on the 3 basic fundamental things. One is the lens formula, second is the magnification formula, and the third one is the sign conventions. Rest all is your calculation. Got it?